Live stream is go. So.
Oh, and can I get? Oh, you put it in. Thank you so much.
Good afternoon. Welcome. How's everybody doing on this first official day of the ICANN meeting? I guess it's been the ICANN meeting start has kind of grown here, crept a little bit. Welcome. So I want to talk about DNS security, DNSSEC. Let me ask a first question. How many of you here have deployed DNSSEC already? Okay, a couple of people. How many of you know how to spell DNSSEC? All right, a few more. Okay. All right, yeah. So we're gonna give you a tutorial series of things that we're talking about, and you will get to see the Emmy award-winning, or no, I guess it's the Tonys. I don't know who's the theater. What's the theater awards? It's the whatever Tonys. Okay, the Tony award-winning DNSSEC tutorial crew here. You can see them walking around with the white T-shirts. We have a skit, and yes, if you've watched engineers perform skits, here we are. Okay, so my name is Dan York. I'm part of the project here that's brought us all together. I work for the Internet Society, but I'm here as part of the DNSSEC coordination group, all the work that happens here. We have a whole workshop on Wednesday that'll be 6 hours worth of DNSSEC deep dives into different aspects around DNS and DNS security and pieces like that. The one detail I guess I can't see here is I don't see the preview. But here's what we're going to talk about today. I'm going to give a little bit of an introduction about some basic concepts around this. We're going to talk about some cavemen and blue smoke and some pieces like this. And then we're going to get into talking a little bit more about what it is about. And then we're going to have our skit. And then after we do our skit, Russ, who's standing over here with the Big Bang t-shirt, is going to come in and go into a little bit more detail around what we just witnessed. And then we're going to go through that from there. So let me begin. In the beginning of our story here, and we should say too, we do have remote attendees. This is going out in the Adobe Connect room. We're also streaming it live on YouTube for people who can't be here remote. It'll be recorded up on there as well. So let's go back to 5000 BC. Did you believe it? DNS and DNSSEC has been around since this very early days. We have our friend here, Aguina. As it says, she lives in a cave on the edge of the canyon, okay? And Og lives on the other side of the Grand Canyon. And Aguina and Og want to be able to talk. But it's a long, long way for them to go and do this, to go from one side to the other. They don't get to talk all that much. On one of the visits, they decide that they could have smoke from Og's fire, and they say, maybe this could give us a way to send signals across the canyon. Now we don't have to go and scramble down to the other side to go and do this. We can just use these smoke signals. So they're chatting away like this. Well then, one day, caveman Kaminsky moves in next door to Ugg, and he starts putting up his own smoke signals. All of a sudden, Aguina on the other side is confused. Which one of these is the one that she should be looking at? Which is the right smoke that she should be doing? They're very confused, for their channel didn't work. So she goes and decides to go across the canyon, back over to see Og, and find out what is it. And so Aguina and Og go to the wise village elder. Caveman Diffie says, I might have a way to do something here. So he jumps up and he runs into Ug's cave, goes to the back of that cave, and he sees this pile of strangely colored sand. Now this sand only exists in Ug's cave. So he says, bring some of that out and throw it into the fire. Now the fire turns blue. And all of a sudden, Aguina is now able to know which fire she should be able to listen to, which one she should watch, because one of them has blue smoke and one of them does not. In essence, this is what we're trying to do, is to provide you with blue smoke, trying to find a way to say, this is the DNS entries that come from me, and I am the only one. My special sand says to all of you that this is my DNS info. And that's what DNSSEC is ultimately about, is how do we go and do this? So let's talk a little bit about what it is. At the high level, we have DNS. We've seen this picture many, many different times. We have some kind of tree, and we'll have COM, Big Bank, UK, IE, SG, whatever. And we have this resolver that knows, it goes out there, it trusts this hierarchy, it goes and sends this to the next level. We've seen these kind of pictures around of what goes on. The challenge is, just like when we had UGG and that caveman Kaminsky, there's no way to know which of those signals, which of those answers is the correct one in and of itself. DNS works on speed, so whoever gets the quickest answer back to you is the one that the resolver will accept as the one that's there. So it's this question of, hey, I can see that, that's the right one, right? So we want to bring out our team to do the first part. Are we going to break this into 3 parts? I'll do my other pieces? Or do we want to do all 3 at once? We always have this debate.
Let's do it in 3.
We'll do it in 3 parts. So we'll do the first part first. So here are our actors, and I'm going to get out of the way and let them do their piece. I'm going to turn it over to Norm, who is going to do the leading of things. All right. Okay, here you go, Norm. And for the live stream, if you guys could say from where you are over to where Russ is, would be cool. We've got our. Take that. Let me get out of the way.
Okay, so what we're going to do is act out some DNS transaction with our incredible acting skills. And it's going to be a bit slower than an actual DNS transaction. So what we have here, staying on here, are the various servers for the TLDs. We have root, COM, and then the big bank, and then the ISP. And I'm a show user. So, scene 1, act 1. So, I'm going to do some banking. I'm going to pay some bills. I'd love to buy a beautiful big TV like this. I've been admiring it. It's beautiful. So, I'm going to do some banking. I'll sit down at my computer, and I'm going to type in www.bigbank.com.
Hello, Joe. You want to go to bigbank.com, but I don't know where bigbank.com is. So I'm a recursive name server. I have no information. I need to go to the root, and as a root. Hello, root.
Hello.
Do you know where www.bigbank.com is?
I'm sorry, I don't, but I do know where .com is. He's at 1.1.1.1.
Ooh, thank you. Hello.com. I want to go to www.bigbank.com. Do you know where that is?
Sorry, I can't help you, but bigbang.com is at 2.2.2.2. Okay.
Thank you. 2.2.2. Hello, Big Bank. Do you know where www.bigbank.com is?
As a matter of fact, I do. www.bigbank.com is at 2.2.2.3.
2.2.2.3. All right, I got that. Hey, Joe. The IP address for www.bigbank.com is 2.2.2.3.
Oh, thank you, Mr. ISP. Now I can go off and happily do my banking at this address. So, what the interesting thing here is that me as Joe user, I asked my ISP to find me bigbank.com, and everything else happened with the server. I just barely waited for the response. So,
Okay, so we just want to jump in here a little bit. So that was the first part. We had Aguina chatting with Og on the server. The server's confused. She doesn't know what's going on. So now we're going to go and figure out how to get that blue smoke and bring that inside here and what it is. At the high level, again, we've got this concept that's as you saw, Dr. Evil was trying to insert.
No, he wasn't.
Oh,
No, we haven't done that. We need to do
You
this
skipped
again.
that too.
well, we messed
Rewind.
that up, didn't we?
Go backwards, Dave.
Okay, this is called what happens when you throw me into also trying to do the live stream at the same time. So now we're going to show you what happens when somebody tries to sabotage this.
Thank you.
See, we have fun.
We do. Here we go.
okay. So, all right, like we're Act 1, Scene 2. Okay, so this time, I'm going to do the same transaction now. I'm going to do some more banking. Bills. Another TV, bedroom. This time, we're going to show you what happens when there's a man in the middle of a tag. Okay, So same scenario for me. Go to my computer, type in www.bigbank.com, Mr. ISP.
Thank you. You want to go to www.bigbank.com, but I don't know where that is. So I'll go ask the root. Hello, root. Do you know where www.bigbank.com?
I do not. You might want to go ask .com. He's at 1.1.1.1.
1.1.1.1. Hello, root. Com. I want to go to www.bigbank.com. You know where that is?
No, I do not. But the name service for Big Bank, 2.2.2.2. Go and ask them.
Thank you. All right, Big Bank. I want to go to www.bigbank.com. You know where that is?
Yes, I do. You can find www.bigbank.com at 6.6.6.6.
6.6.6.6. I'm going to remember that for a long time. Thank you. Joe, the IP address for bigbank.com is 6.6.6.6.
Oh, thank you, Mr. ISP. Now I've got to go off to this address and do my banking and hopefully get another TV.
Now we talk about what you saw there. All right. So we saw them chatting. We saw that they don't know what's the issue about. So now the question is, how do we get that blue smoke in here? How do we do that? How do we bring this in here? And so what we're going to see is that, as Jay just did, as he came in as the attacker doing this kind of thing, something happened here. He was able to inject himself in there. So now we're going to talk about what goes on. What happens with DNSSEC is that in DNSSEC there's a signature added. There's two parts to this. There's a signature added to the information that gets passed. So when, as you saw, when root and big bank and the COM name servers, when they pass the information to the ISP, they provide the DNS information, and they also provide signatures. And these are the blue smoke, the thing that makes it unique to that particular piece. So they provide signatures. Now the second part is that the ISP, Jacques in this case, is checking those signatures, what we call validation. They're validating the DNS signatures. These are the two parts that make it work. And they're separate. Each one of you could go back to your houses, your homes, whatever else, and you could turn on DNSSEC validation in your network or in your environment. Often this is done by ISPs, or it could be done on an enterprise network or a home network. You can do DNSSEC validation there. The other part is you can sign your domains. They're two separate pieces of the puzzle. So we're going to look at that and see how this works. So the resolver, as we said, checks these. It has this, what's called the chain of trust, that goes all the way up to the top of the root. This is the root public key, as we call it, this root that makes this whole chain of trust, so that we know that the signatures are valid all the way from the root to .com to Big Bank. I see we're improvising some signatures right now, but we'll be able to go and show how this chain works. So what will happen, as you'll see, is that because there is this signature, and these signatures that go all the way down, this time Dr. Evil may have a few little problems getting in here. Let's come and watch this scenario here. Come on back. Jacques. Oh yeah, well first we have to do a little exchange. So what's going to happen here is...
Hello, here, guys. I am Big Bank, and this is my signature.
Cool. Good to meet you. Hello, root. I am .com, and this is what my signature looks like.
Well, hello, .com. I am root, and this is what my signature looks like.
I'm the ISP, and I got the root signature here. It's built in my software.
Okay, now everything's DNSSEC enabled. Everybody's signed their zones. Now we're going to do the same transaction again. More banking. Gotta get that TV. Lost it last time. Lost everything actually. Okay, same scenario. Sit down on my computer, do some banking. We would go to Mr. ISP. I'd like to go to www.bigbank.com.
Okay, Joe, you want to go to bigbank.com? Let's see where we go. Hello, root. I want to go to www.bigbank.com. Do you know where that is?
No, but you can go to .com at 2.2.2.2, but I need to sign this
check. Okay, everything's good, thank you. Hello.com, I need to go to www.bigbang.com. Do you know where that is?
Wow, bigbang.com is really popular. I don't actually know where they are, but you can ask the name servers. They're at 2.2.2.2, and here's the signature from me showing that that's correct.
Thank you. Now let me check. Everything's good. Good signature. Thank you. Hey, Big Bang. I want to go to www.bigbang.com. Do you know where that is?
I certainly do. You can find it at www.bigbang.com 6.6.6.
Let me check the signature. No signature. Hey! Not too bad. Sorry. Oh, that was bad. Okay, Big Bang. I want to go to www.bigbang.com. You know where that is?
Indeed, I do know where www.bigbang.com is. It's 2.2.2.3, and here's my signature.
Oh, that's good. Signatures work. Everything's cool. Thank you very much. Hey, Joe. I can guarantee the IP address is 2.2.2.3 for bigbang.com.
Awesome. Thank you, Mr. ISP. Now, with everything verified and validated, I can happily go off and do my banking and feel confident that it's authentic. That was.
Let's have a good round of applause for the DNSSEC players here, or something like that. So anyway, thank you, folks. We'll be nominating that for the Tony Emmy, whatever that is, or something like that. So, in all seriousness, if you do want to show other people this, it is now on YouTube. So, anyway, that's a bit about what DNSSEC was. So let me ask you a question. Do you feel better now? Do you understand a bit about what it's trying to do? The two parts to it? I'm seeing some people saying yes, some people saying maybe no. Okay. So Russ is going to come up and talk a little bit more in a bit more detail about some of the parts of this. But remember again, the two parts. You had Jacques as the ISP who was doing the checking, the validation. He was checking to make sure the signatures were there. And the other part was that the other people had gone and signed those signatures. That's what makes DNSSEC work. And everybody who signs it has their own special keys. And they go and do that. And it's their special piece, their blue smoke, as we would say, that helps determine that that is their information. So I will pass it over to Russ to do further information. And here we go. I'll come back at the end.
Okay, thank you. So we'll see if I can get my buttons pushed the right direction here. Other one. And next. Okay. I'll get there. Hey, there we go. And I feel like I'm right in front of the screen. So maybe I was, maybe I wasn't. Anyway, I'm Russ Bundy, and been involved in DNSSEC for quite a while. And we have discovered that we're really in a situation where you need to have some idea about why you need to do DNS security and what happens if you don't. So the biggest single issue is that the names that you get out of the name servers, just like you saw in the last skit, can be wrong. And in the skit, we talk about going to the banks, or it could also be going to your search engine. It could be going to your stock management and stock watching area. So any place you go, almost anything you do on the internet, you're going to be making use of DNS. And so when you think about what it is that your application is, whatever it might be, that's what people are going after when they try to attack DNS. Just like in Joe User's case, where they wanted to steal his money out of the bank so he couldn't buy the TV, could be intercepting mail, could be intercepting chat, whatever. So it really is not DNS itself, it really is what you're doing on the internet that people, when they try to misdirect or hijack DNS, are trying to get a hold of. At one point in time, and this has disappeared off the internet, I am glad to say, but I did find a course that was taught in university about how to write software to hijack DNS. That was actually being taught in the course. I looked through the syllabus that was up there, and there was nothing that talked about ethics or that this was wrong. The professor was just using it as a nice, simple exercise in software development to do something a little bit, quote, different. And so it really is not that complex, and there is, in fact, a number of implementations for DNS hijacking out there. So it's not really that hard. So what is DNSSEC actually doing? Well, you saw in the skit, it makes sure that the answer that comes back to the question is the correct answer. It's the information that was put into the system, into the DNS system itself, by the holder of the information. In this case, it was the bigbank.com. So it was the information for how you get to www.bigbank.com. So when the ISP goes through his validation process, he can tell that it came from the originator properly because he had the key chain that he followed, and he started from the root trust anchor. And that also gives a validation of the technical correctness of the contents of the packet. So in security speak, it's source authenticity and integrity is what DNSSEC is doing for you. So just a little picture here that is another way of illustrating what we were showing in the slide. When Joe User asks a question of his ISP, it goes off to his recursive name server. The recursive name server asks the name server associated with the name, what's the name for it? It comes back to the recursive name server hands it back to Joe User, and after all of this occurs, then Joe User can connect up to wherever he's going in our skit, www.bigbank.com. So what happens when you get to the website and you see that you are getting DNSSEC validation? This is a specialized website that we've tailored because it's made to help deploy DNSSEC to show whether or not you're using DNSSEC. It's not a standard. This is just purely a convention. You see a little green DNSSEC check. There's a couple of other websites around that do it, but you don't normally see that green check mark unless you're going to a site that's set up for it. Now this is where you are using a browser that does not have DNSSEC validation, but going to the same website. And so when you have the warning sign, it says, oh my, okay, you are not DNSSEC secured, so you don't know if you actually got to the right place. And so let's put in Dr. Evil here in our picture again. So Joe User sends his query again. Dr. Evil is listening on the line, and you saw our Dr. Evil, Jay Daly, doing a great illustration of how overlooking and eavesdropping and trying to get information could be done at different places in different ways. And in this case, Dr. Evil hears it and sends an answer back, and so the answer says, go over, I should fix the numbers so they're the same, but the fake website instead of the real website. And although the query continues to go out across the internet and come back, it doesn't matter to Joe User's computer because it previously got an answer and it took that answer and used it. So the proper answer, though it came back, effectively falls on the floor. So when you include DNSSEC validation, what happens is the validator says, the answer that's coming back from Dr. Evil is wrong because it doesn't meet the requirement for the cryptographic check that is how we do DNSSEC. And it throws that answer on the floor, and when the proper answer gets back, then it can take that. So in this case, these are some screenshots from an actual live demo that we did of the hijack in a meeting to make the point. So You see those two screenshots. I know they're a little hard to read on this somewhat small screen, but in fact, if you look on on the left side of the screen there, you see the top story is .org shares Comcast DNS Sec advice for ISPs. You look on the screenshot on the right, you'll notice that's actually the second story on the page. Most web pages are made up of multiple links that have multiple names. So any one of those names can be hijacked. And in fact, that's exactly what we did in this case. And we inserted content. We didn't change content, we inserted content. The rest of the page is the same. So there's all kinds of interesting and different tricks that you can accomplish doing a DNS hijack. And that picture that just came up are the number of queries that it took to fill a home page of CNN.com about 7 years ago. That's about what it takes today. Keeps getting bigger. And so what's really important, and the stomp the foot professor point here, is what matters about DNSSEC is the integrity and the content of the DNS data itself. A lot of people think the most important part in a DNSSEC zone is the crypto keys and the DNSSEC associated stuff. It's not. It is all of equal importance, but if you want to rank anything, what's more important is the actual zone content data itself, because that's what tells the rest of the software on the internet where it's going to go. It's the DNS content. So here's another picture of a slightly different illustration, and how does one go about doing DNSSEC things. You've seen there's a lot of pieces of DNS, and they're illustrated in a way there. And on the right is the client, and the recursive server is in the center bottom, authoritative center top, and the actual zone data that gets put in is on the left side. And so when you do DNSSEC, if you're the operator of an authoritative name server and you have zone data, then you sign that zone data. And if you're operating a recursive name server, then you get the root key and use that to turn on validation of data as it comes in from assigned zones. If you're a user, then you want to use some of the tools that are available that are mostly free. If you are just if you're a user that has central support, you need to go to your central support and ask for it. So depending on the organization that an individual is in, there'll be different kinds of things. If it's an organization that's very DNS centric and its main business line is DNS, you're probably going to have a pretty competent DNS operations staff, or you will have outsourced it to a competent DNS operator. If you're in another type of organization that just makes use of DNS as sort of, I need DNS to work on the internet, you might or might not have staff that's able to support it. So it really does vary depending on what the particulars of the situation are. So if you're, say, a registry that's responsible for a TLD operation, you better have a pretty good DNS qualified staff. Chances are they can do your DNSSEC already. If you're in the new GTLD, something says it's going to turn off here. I'm not sure what it is. Anyway, something is going to maybe go blank. I hope not. I'll talk faster then. So if you're an enterprise that is purely vendor dependent, then at that point you need to go to your vendor. Oh, thank you very much. And ask your vendor. I need DNSSEC. When can you provide it for me? And the good old internet end users, all of us, make use of as much DNSSEC as you can and ask. That's an important thing, because many times when through the efforts of getting DNSSEC out in the news, people will come back to us and say, but nobody is asking. So that's why in these sessions I always urge folks to ask. And so protecting your zone data, that's really what you need to do. The keys and the crypto material provide that protection, but you need to also think about protecting your zone data if you're a zone operator and providing data for the internet, because that's really what counts. So when you plug these pieces in, the simplest piece of getting a DNSSEC deployment in place and running is you've got some signed data from someone who's operating an authoritative zone. You've decided to do DNSSEC. You've signed your DNS zone content, and that adds the appropriate number of records and type of records into the zone. That zone data is loaded into the authoritative server, and a validating recursive server has to get the root trust anchor, the root key, the root trust anchor it's called, because that's what you start from and go down through the tree, and you have DNSSEC going on. Now, depending upon where you're at, you may already have it, and it's always great if you can ask your providers, I really want to get DNSSEC. Am I getting DNSSEC protection? And they'll come back and say, yes. But sometimes, in fact, still a lot of times, the answer is no. So that's why asking is so critical and so important. But in terms of how you can impact your organizations and the type of organization you're in, because there are many different parts of DNS and DNS security. If you're in an organization that is highly centric on running a DNS activity as part of their business, then there's a good chance you can do these things that you need to do for DNSSEC in-house. If you're not, if you're outsourcing them, whether it's for your operation or you're part of an enterprise, then you still need to ask the question, and whoever the service providers are, get them to give you a commitment about when they will be doing DNS security. So that's the main set of things we wanted to present and talk about, and we're available for questions. There's a number of us here, and so we can take whatever questions you might have, and this is what we like to get. People say, hey, what about? And, oh, we're going to need to run a mic around. It looks like we don't have mics on the table. Oh, Kathy has one. Okay. So, open for questions.
Yes, think of your questions, because you kind of have some after all this, I'm sure. I can see faces back there that say, what? Oh, please do state your names for the record, etc. Thank you.
Dennis Hurley. I represent a small ISP based here in Ireland. What's involved for a general ISP to move from today, say, non-DNSSEC to DNSSEC? Is it a large CapEx for hardware, software, etc.?
Most of the mainline production software that's used in ISPs for resolution already is DNSSEC capable. It's not 100% across the board, but that, depending on what the package is, it is often a matter of simply turning it on. But the important thing before you actually go through and turn it on is to go through a testing process and prepare support people, because there are some other things that can occur in the end user view. If something fails, it might look a little different to the end user. One of the largest ISPs in the US, Comcast, and they may be the largest, I'm not sure.
They are the largest.
Yeah, so they have universally fielded DNSSEC, both validation and signing their zones. And they went through an extensive training effort prior to actually turning it on.
Yeah, I mean, the reality is most of the code, like you said, bind, NSD, Power DNS, whatever you're using for resolution, if you're using whatever it may be, Unbound, all of those, it's often just either uncommenting a configuration or putting something in. They all support it. that's out there. Windows Server 2012, if you're using that. I mean, any of those kind of techniques. The validation side is actually very easy to enable. And so you can go back and immediately start doing that, and people can, and it doesn't really require much of a change, or it doesn't have much of a increase on the capacity or the the amount. I mean, there's additional checking it's doing, but it's not a remarkable amount for the typical ISP. But the big change to what Russ was talking about, if Dr. Evil tries to get in there, what happens is there's a failure to get the information. Your validator can't get the information. And so it sends back to the other, I mean, what typically happens is it will send back to the user and say, I can't get to that page. So the problem, the classic example is what happened with Comcast was NASA had signed their .gov domains, nasa.gov, because the U.S. federal government has been very strong in working with U.S. government agencies, such that about 88% of all of the .gov domains are now signed. But when you're signing a domain, there is some additional work that has to be done, because every time you update the domain, it has to be re-signed. There's also that private key, the thing that makes the blue smoke, that typically has an expiration period of about a year, is the typical implementation that we do. And so a year after you sign it, you have to roll that key and have a new key. Well, the folks at NASA didn't do that right. They blew it. They didn't do the key rollover correctly. And so all of a sudden, their keys expired. What happened that made a perfect storm that made this really bad was it was on, do you remember the day when everything was going to go dark on the web for SOPA PIPA? Remember there was that day when the SOPA PIPA, and there was protests, and Wikipedia was going dark, and everything was going dark and all that? Well, NASA's keys expired on that same day, okay? And so all of a sudden, everybody who was using Comcast as their ISP couldn't get to NASA's website. And it wasn't like, there wasn't an error message that said you can't get to NASA's website. It was like, server not found, okay? But of course, people could go and whip out their cell phones, look at this, and their mobile network operators were not doing DNS validation, so they saw they could still get to NASA here. So what happened? Comcast blocking NASA all over Twitter, everywhere else. It was this big, huge thing, and they're like, wait, no. We're checking it, okay? So one thing from an ISP perspective is you may just need to train your tech support folks to know that if somebody calls up and says, we can't get to NASA or whatever, that one other failure condition could be that there's a failure in the DNSSEC validation. And there's some very easy sites that let you go and you can just plug in, NASA.gov, and you can see, boop, 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 bunch of green circles, red circles, oh, hey, here's the problem. And so you could be able to go back to your customer and say, well, no, we're protecting you from somebody putting bogus addresses in there. But in this particular case, there was a configuration failure, and so there's an issue with that. So that's the one thing that you need to be aware of as an ISP. Otherwise, you can start validating right now.
And one could go through a step-by-step process and test with small group of users and that sort of thing too. But right, the validation end is really is straightforward.
In the European market today, could you give me any ideas what percentage of service providers are using it?
Sure, it varies widely. We have some stats up on our Deploy 360 page that go and show this. Some places like in Sweden and the Netherlands and the Czech Republic, there's a very high percentage of ISPs who are doing it, very high, and I think Slovenia now too as well. And actually Jeff Houston at APNIC does some statistics that he does, because they can show you on a country by country level of who's doing it. And so it varies. In some of those, there's a lot, because there's a lot, they've gotten together, they've worked on that. In other countries, there's almost very few. If Michele Nalon were here, he'd probably tell me there's very few in Ireland who are currently doing it. There's 2, somebody says. Awesome. Excellent. That was a better number than I was going to give, so that's awesome. 2 ISPs. Let's build up more. I see
Back the
gentleman.
Yeah.
Okay. Thank you, Kathy.
The root name server is bringing you the mic.
All right, thank you. My name is Otuto Twine. I want to ask, an end user of the internet, how would such person be concerned about DNSSEC, because the techies could be careful when they're on the web, but an end user wants to go to bank.com, make some transaction, does not know what DNSSEC and security is all about on the web. How could such person make that? Because we need to talk to such people also who are not informed.
Sure. So one of the challenges is with the end user. There's been one of these discussions. Should the end user even know? Comcast has opted that, the end users don't know, and that's the general thing. It's just there's a failure in that. Because one of the problems that's come up, and the reason why the advocacy around this is, how many of you look at that little lock in your web browser? All right. Okay. How many of you ignore that when it goes yellow, or do you even notice if it goes yellow? I see a couple people. Anybody notice what happens when you get those warnings coming up about the TLS certificate? Do you actually pay attention to them, or do you just click through? All right. How many people pay attention to them? All right, good crowd here. All right, it's probably why you're sitting here. How many people think that their parents, husbands, girlfriends, wives, somebody else out there who are not in this room, how many of you think they pay attention to those, or how many think they click through them? Click through them? Pay attention to them? Yeah, I'm not seeing hands. Okay. So the debate is, do we expose more to the end user? Do we give them more information like this? Because will the average user care? And the average user probably won't. And so it's almost a case of giving them too much information that they're not going to pay attention to. Oh, okay, so my lock screen or whatever else, or I have this other key. And for all of us in this room who want to look at this, there's some very cool things you could do. There are add-ons available from the CZ-NIC Labs folks that you can add on to Chrome, Firefox, and IE, which I browse with, that can let me go and see what if somebody has a valid DNSSEC signature, and it will give me a little green key in the browser bar. For us, that's cool, because we can do it, and we can use it, and we can see it. For the average user, general feeling right now is it's one more thing they'll ignore. And so the effect really is to look at how do we do it at the network level, at the ISP level, at the enterprise edge, to just provide the protection as if it's just, it's just blocked. Now, there's a separate issue about how to educate some of those end users about why they might want to ask for DNSSEC validation and why they might want to look at how they should get their domain signed. And that comes into this discussion we're sort of having here about what is the benefit of DNSSEC and increasing the trust in your domain name, in your system, in your network, increasing the trust for your users that they can trust the information coming out of DNSSEC. So that's that kind of it's more of an advocacy discussion that needs to happen in the end user space. Did that answer your question? Okay. Anybody else? She's going in the back.
Yeah.
Right? Here,
Got one right here. Go ahead, Kathy.
Thank you. Was it right here? I'd just like to understand a bit more the difference between DNSSEC and the TLS SSL certificate.
Sure. So if you think about, they work together and really well, because if I have a TLS certificate, what we used to call SSL, what that does is it encrypts the connection between you and I, or the bank and you. DNS and DNSSEC has nothing to do with confidentiality. It doesn't encrypt at all. All it does is it says, these are the IP addresses you were looking for. It says, these are the right IP addresses that you got out. The information that you're getting out of DNS is the information that the operator put into DNS. That's all DNSSEC does. So you know you're talking to the right place. Now once you talk to that right place, the TLS certificate that you get then provides a further assertion of who that person is, who that entity is, the server you're talking to, and it encrypts the channel. Now the challenge you get into is the two need to work together, because you can buy a very fancy EVSSL certificate. You can get a really, one that turns the whole address bar green, okay, whatever else. But if people don't get to your server to get that certificate, then they're not using it. Because they could get to this gentleman's server over here, who's actually the attacker, and he's bought a TLS certificate from somebody else, who he was able to forge, or get a domain name that looked similar to yours. So you connect to his site, you get the little green lock up there, because you've got a really good TLS certificate coming from him, Okay, you've got encrypted communication, you've got all of that, you're just talking to the wrong server. So TLS and they work together. And then, are you about to say?
Yeah, the reason I put this slide back up is this is an attempt to illustrate how you can end up going to the wrong server. This is where the Dr. Evil jumped in, gave the incorrect address, and in this case, you go off to the attacker's website, but in the scenario Dan was just describing, the attacker has a certificate that will validate in your browser, either by trickery or because he bought a real, true, legitimate certificate, and you maybe typed the name a little bit wrong or something, but it will give you a valid TLS SSL connection to the wrong place.
Now, one way that people have looked at to fix this, how many people have heard of the DANE protocol? Anybody? A few people at the back there. So DANE is an exciting new usage of DNSSEC where it combines them, and what it does is it lets you put the TLS information into DNS and sign it with DNSSEC, and it can be either the actual TLS certificate you want to use, or it can be the name of the certificate authority that issues the certificate or whatever else. So now what happens is when you want to connect to your bank web server, you go to DNS. DNS gives you back the IP addresses and the signatures to validate those are them. It can also give you back a record that says, and when you connect to that site, you should use this TLS certificate, or you should use a TLS certificate signed by this certificate authority. One of those things. That information comes back to you. You can now connect to the website because you've got the correct IP addresses, and when you get the TLS certificate coming back from them in the normal TLS handshake, you now have an additional way of validating it to know that that is indeed the correct TLS certificate that you want to use. Wes Hardiger, who was here earlier, but he went to go somewhere else, but if you'll see him around here, and you'll see him on Wednesday, he's done a whole presentation on how this is being used with email servers and using it for TLS between email servers to be able to go and use DANE to know this is the TLS certificate that I want to use to connect to this particular email server. So DANE is this mechanism of combining TLS, the confidentiality and the pieces that you get with the integrity checking you get out of DNSSEC so that you can know what's there. And there's people implementing it in email, in Jabber, in voice over IP protocols. There's been some work on the website. There's some plugins that will do it. The web browsers, Google, Mozilla, others have not yet brought this in. They have some of their own speed concerns and some other issues that they're still working through. And there's proposals in the IETF DANE working group. Warren Kumari, who was up here as one of the characters, he's one of the co-chairs of that group within the IETF, and they're working on how this could be used in more PIT systems out there. But that's what DANE is. DANE is using TLS with DNSSEC. Other questions? I saw somebody back there.
Good evening, Mohit Patra from National Internet Exchange of India, NEXIM. So my question is, as I understand that DNSSEC is not a foolproof solution because it just secures the connection from the ISP to the authoritative name server, right? But what about if we talk about the end-to-end security, that is the connection from the stub resolver to the ISP?
So the validation, what you're saying about is the validation of where the validation occurs. The attacker could still get in and change the information, right?
Yes, the connection from the stub resolver to the requested name resolver.
So the reality is validation can occur at any point in the process, but depending on where you do, there is still an attack surface for Dr. Evil to swoop in and give the wrong information. For instance, Google's public DNS servers, the 8.8.8 and the 8.4.4, as well as VeriSign's new public DNS servers that they've rolled out, both of those do full DNSSEC validation. So everybody who's using the 8.8, etc., those are all doing DNSSEC validation right now. Okay, But the challenge is, if you're sending your query, if your ISP is sending if your application, your web browser, is sending the query out to the resolver and it's all the way out at Google's public DNS server, there's a lot of space that Dr. Evil could swoop in there and still get your information. What we've seen is that's available. We're getting more and more ISPs who are doing it, so you're bringing the zone closer. Then you're seeing people we're starting to put it into customer premise devices, so home routers and edge devices. Now you're moving that validation even closer. I'm a DNSSEC geek, so I run a stub resolver, DNSSEC trigger. I run it on my laptop that does the validation right there. And so now I further reduced where Dr. Evil could swoop in, is that he would have to go and compromise my machine. And you've seen some applications that have built the DNSSEC validation right in. If you see some of the VeriSign Labs guys running around, they've got an API called GetDNS, which includes the DNSSEC API or DNSSEC validation directly in that. The DNSSEC Tools project that Russ is involved with has DNSSEC validation right there that you could build into your application. So it's not foolproof because it does depend upon where does that validation happen.
And in general, the people who have been involved in DNSSEC for a long time have pretty universally said that the closer you can get it to the software that's sitting in front of the user, the better. And there's even been some arguments amongst them is it okay if it just runs on the general resolver on, the stub resolver on the machine, or does it have to be built into each application? That comes down to an argument of how secure the software on the machine is, but it gets to the machine, and there's pretty universal agreement in the DNSSEC world that in the long term, that's where the validation is best done, is on the end user's machine.
And we're seeing, for instance, the latest release of Fedora in the Linux world has DNSSEC validation turned on by default. So anybody who's using that on their servers or other pieces would have DNSSEC validation automatically on there, so at the device level. Other questions? I saw a gentleman up in front here too.
Question over here? Yeah.
Okay, go ahead. Yeah. Yeah, go ahead.
Okay. You sort of answered it, but for the end user side, at the browser level, I've seen plugins for DNSSEC, and then some seem native. Are there any recommendations on that?
So right now on the browser side, it's plugins at this point in time. We've had long discussions with the browser vendors and the pieces like this, and one of their concerns right now has been, they're all fighting on speed and on the speed of resolution, speed of coming up with pages, and that additional checking does introduce a couple microseconds, but this is the world in which they're working at. Now, there's some new work happening in the DNS working groups within the ITF that would pipeline some of those queries and do some other things which look like they would go and help address some of the concerns that the browser vendors have around that. So in the meantime, we're seeing a lot of pickup of DNSSEC in people using the plugins. We're also seeing a lot of it in other places, in the IM space, in VoIP, in SIP-related communications, in email opportunity, in some of the email work that's happening in there. So it's happening in a lot of the other services that are happening out there. And I think that's part of it too, is some of the browser vendors have said, well, there's not enough signed domains. So we're not going to implement this until there's a lot of the signed domains. And so what we're seeing is through some of the other pieces, we're seeing a rise of that. Now, here in Europe, there's some great stories around that. There's over 2 million .nl domains that are all signed. There's a huge amount in some of the other different spaces that are out there that are doing that. So we're seeing a lot of the growth of that. So we're still in, the reality is DNSSEC only really started to be useful 5 years ago when the root was signed. And so what we're seeing is now, over this last 5 years, we're seeing this growth path, and we're seeing the increasing growth in that.
So just a quick follow-on and related. So, because I think what sounded like two possible contradictory point of views. So, one, I think I heard you say that there's one conversation about containing at the network level or at the ISP level. The other is bringing it all the way to the end user.
Well,
Is that just a process, or is that a perspective, a worldview?
I think it's an evolution, because right now we're seeing that the deployment's happening at the ISP level and at the public DNS level. We're seeing it out there, and then we're starting to see it happen at the edge of the network in operating systems and CPE devices, and we're seeing a few vendors putting it into their applications. But as people become aware of what it can do, and as some of the vendors start to look and say, oh, I could do that with Dane? Wow, that's cool. Let me look at how to build that in. So we'll see more of that. It's an evolution. In the back.
The question is in two parts. Is there any good reason that an operator of a name server can give for not turning on validation of DNS requests? And the second half of it then is there any good reason for a domain owner not to turn on DNSSEC or request their operator to sign their zones?
So the first answer is I would generally say there's very few reasons for somebody running recursive resolvers to not enable DNSSEC. The one caveat would be if they're not aware of the other error cases that can come up. Like we were saying, the failed validation could be because of a failed configuration. If the support staff isn't aware that this is something that they should be, that could happen, then just somebody flicking uncommenting a line in a config file and not cluing in the support staff may not be a good process point. But there's very few reasons why somebody wouldn't want to do that. Some of the very large scale folks doing the resolvers, the bit of overhead that it costs to do that extra checking isn't a whole lot when you're at a typical ISP level. When you get to be at a very large scale, then, and I don't know what quantity it is, but there is some checking you need to do just in terms of capacity. But for most folks, it's not an issue. The second, Russ, would you agree with that? I mean,
right.
Yeah.
It's really not an issue on the validation side. Primarily, if you take the support questions into consideration.
Now, on the signing side, it does get to be a little bit more complicated because there are a number, like for me, I have my domains hosted across a number of different DNS hosting operators. A couple of those have made it very simple for me to sign my domain. I go in, I check a box, and I'm done. They take care of all of the signing of it, the regular, because every time I update the records, they have to re-sign the zone. They take care of rolling the keys for me every year. They do all of that. It's simple. In one case, I pay $30 a year to have a special added secure DNS service. In another case, it's part of the overall thing. Some of the other DNS operators I use don't have any way of me doing that. If I'm going to take it on myself, if I'm an enterprise and I want to operate my own DNS authoritative servers, then I have to think about that extra process of signing the zone every time it gets changed, which most of the things like bind or any of these, not, etc., they go and they automatically do all that. So the signing part is fine. But it is a key rollover every year when I'm rolling the primary key. It's added process steps that I have to think about in there. So that's the thing to think when you're going to sign your domain. The first step is, does your DNS hosting operator, which could be your registrar, it might not be, but whatever, does the person doing your authoritative name service, is it easy for them, do they offer the signing service? If the answer is yes, and you can just check it, then boom, you're done. If they don't offer it, then you have to think, as in one of my cases, I had some domains with a registrar who was not supporting DNSSEC. I had to actually move them to a different registrar eventually to be able to, because I gave up on the registrar for providing any of the support. So I had to move to that to do it. So you may not be able to work with that. And there are some TLDs that do not allow DNSSEC yet at the top level. We should explain, there's one more little piece of this. To make this web of trust work that we did here, the root, the .com domain had to be able to deal with signatures. .com does. So does .org, so does most of the original 22 that were there, and so do all the new GTLDs. Many of the CCTLDs do, but there's about 100 that still do not yet. And we're slowly chipping away at those over the time, but there are some out there. So the CCTLD, or the TLD, has to support DNS at the top level And then there is one more piece that I don't want to really dive into, but I'll say the registrar has to be able to pass these records up to the TLD. There's something called a DS record. Has to be supported in there.
So this is why we've tried to kind of abstract out what some of the pieces are, because there are quite a few individual pieces when you look at the entirety of DNS and what's involved. If for the second part of your question for an authoritative name server, in terms of size of operation, the largest TLDs by number of names are all signed. We haven't looked to see how far down it goes, but I mean, clearly you have COM, and that's, by far and away the top of that pile, and the other ones below. One of the things that some of the smaller CCTLDs have given us feedback on is they just don't have the financial resources that they believe they need to incorporate the changes, because they're running on really old, ancient stuff, and they just don't have the money to buy the new hardware that will run the newer open source software that will support it. And that can happen.
And as a result, you've seen some companies offering services to do that kind of
Right.
signing. I saw a gentleman, did that answer your two questions?
Yes, thank you.
Okay. Gentleman in the back there with the blue shirt and or teal shirt.
Most of the questions you have answered. My only concern is that you have said TLS SSL could be compromised, and some gentleman could take a very good equivalent of that, and that could work seem like that server. So can't that happen with your DNS Sec?
No. Well, so
it could happen.
No.
If he wants to take the identity, he could take the complete identity of the SSL as well as of DNS Sec, and then I don't have anything. Then you will propose me a third.
So there's two answers there. If somebody goes and they set up a separate name server, and they're going to say they're from, ICANN.org, and they go set that up, they have a separate TLS server, they do something else, whatever else, they go and try to do that. They can even sign that record that they're serving out of their DNS server with a key. But here's the point. There's this chain of trust that goes from the authoritative name server for ICANN.org up to the .org registry, up to the root. And so so ICANN has signed their domains. There's a hash of that signature that is now in the .org registry, and is there. It's called this DS record that's out there, and that is then tied up to there. So a DNS Sec validator would check all the way from the root down. So if somebody goes and tries to set up a separate server, a separate DNS server, and serve out records and sign them, they can do all that, but they can't get that signature, the hash of that, they can't get that up into the .org. So when a validation, when a DNSSEC, when a resolver that's validating checks that, it's going to say, wait a minute, you're giving me signed records, but they don't validate all the way up to the root of DNS. Okay, so they're going to check that. So that's the good case of where it works. Now the one gotcha is, if somebody compromises your registrar, if they go in and hack your account on the registrar, and they go in there, then they can upload whatever records they want, and they can put in whatever records they want, and they can do that. That's separate from DNSSEC. That has nothing to do with DNSSEC. That's just regular DNS. So DNSSEC, if there's no compromise of the actors in the process there, DNSSEC prevents somebody else setting up a domain name in your name and doing that, and that's what it prevents. But but somebody else owning your name servers, and taking over them is that you've got bigger issues than DNSSEC at that point.
My another question is that in a chain, the weakest link is the strength of that chain.
I'm sorry, what?
when you have a chain,
Yep.
the weakest link, if you have a weak link
In the chain. Yeah, in the chain. Yeah.
but then that is the maximum strength of that chain. That would break from there. Even one ISP is not doing DNSSEC. Then the whole of the process is compromised. So you said that it is dependent on the ISPs. So even if one ISP in the world is not doing it, then all those customers who are connected to that ISP are not secured.
Correct.
And this is one of the reasons why I was saying, ask your service provider for DNSSEC, because no one can centrally dictate to people that they must do DNSSEC. The customers are key in where you're describing.
What we're finding though,
in that case, the awareness
Exactly.
about the DNSSEC is the key that should be provided.
hence why we're here, hence why we'll have the discussion that we're having on Wednesday, the efforts that we're doing. And also we're starting to see, that this become more of, just best practices that ISPs should be doing. And as we're seeing more pickup and more usage of it, it's becoming something that customers are asking their ISPs and saying, hey, am I getting this additional protection? And if not, can we go and do that? So it is that. I think we've got time for one or two more questions. So something else, I see two more right here. Yeah, go ahead.
Hello, I'm Horatio. If your country domain name is not DNSSEC, then your subdomain, how secure is it? Because it won't validate up the chain.
Correct. There's at this point, if your country code, if your CCTLD is not yet signed, then what we would strongly suggest is that ICANN has a team of people who are standing by to help you sign your domain, and they will be glad to go out and do that. Seriously, Rick Lamb, who you'll meet if you come to Wednesday, but he's around here as well. There's a team here at ICANN that will work with your CCTLD to do a workshop, to do the pieces, to get that signed, to help with the process in place to make that happen. Because that's what you need to have in order for the subdomains to then get the added protection of DNSSEC.
Another quick question. How much overhead it's being added on the request times in general when you enable DNSSEC?
It depends.
I mean, if your domain name serves like gazillion self requests,
right.
It kind of tends to maybe impact it.
Yeah, and this is one of those. For the average ISP, for the average person, it's been generally small. It's been like under 10%, an increase in the amount of bandwidth and things that you need to see. Some of those depends upon the number of, Jeff Houston's some number of presentations from APNIC around when you get into a large number of bad queries that can generate more traffic and more pieces around that. So it's something to look at. The normal stats we've seen right now has been that for most ISPs, it's not a huge. I mean, it might be a 10% increase or 15% increase in the number of the network bandwidth for queries or something like that, but generally not a huge amount in the scope of things. Obviously, when you get to be larger and larger scale, then you start to think about those kind of things.
Well, and there are techniques that you can use in terms of pre-deployment testing.
Yeah.
That you can actually set up a server that is doing validation sitting right next to your existing production server that's not doing validation, and actually collect, just feed a duplicate of the data into the one that's doing validation. And you can study and look yourself and see how much will it impact the performance of my machinery in my place.
So I think we have one more. I saw it right there.
There is a competing, I think, I'm not sure whether it's a standard or not, but DNS curve is there that is based on elliptic curve cryptography. So is it complementary to the DNS Sec or is it something different?
So there's a, what would you say, DNS curve?
Yes.
Yeah, DNS curve actually looks to solve a different problem, which is the encryption of the connection between the stub resolver and the recursive resolver. So it's really looking at how do you make sure that Joe, in talking to his ISP, how do you ensure that that connection is secure? And that's and that's one of the technologies that people are looking at to encrypt that last piece. There's also a working group within the IETF called DPRIVE, which is DNS privacy, which is currently looking at a mechanism as well that would use this in DNS over TLS and some pieces between that. So it works on that. Now, one note that you did mention about elliptic curve, one of the things that we're seeing is that there is some concern about some of the cryptographic algorithms that are being used within DNS for the signing of keys. And the good news is DNSSEC was created from the beginning with the idea that the algorithms would evolve and would change. And so, for instance, a lot of the keys that are out there that are signed were signed with RSA 1024-bit crypto or RSA 2048. Well, now we're seeing a migration right now to using the elliptic curve in ECDSA, which gives you a smaller signature, which, to get to your point about the scaling of things, and one of the entities, I don't see, Oliver Goodmanson is with Cloudflare, and they're a large DNS provider and CDN. They're looking at signing their domains, and they're doing it with ECDSA so they can get smaller signatures, which can lend to more packaging and a more secure cryptography. There's some new crypto algorithms that are coming out of the cryptographic research group that are looking at how do we feed those into DNSSEC as well so that they can do it. Now, the challenge with that is that you've got to make sure that the resolvers can check those new signatures, and you've got to have the signing software be able to sign it. So it takes a bit of time to roll those out. But there's definite interest in rolling the elliptic curve crypto into the DNS environment to do that. Did that answer your question?
Yes. One more question.
Sure.
Is DNS curve an IETF standard? I'm not very sure about that.
No, it's not. It's a product out of Dan Bernstein and some of the others who are involved with that project.
Okay, one last final question. If DNSSEC validation fails, some message is displayed in browser, or what happens?
So when DNSSEC validation fails, it gives back what's called a serve fail in DNS speak, which means that the records are not found. But there's nothing there. There's no thing. So what would happen in a browser would typically be, it would say, server not found or something like that. So, and this is one, I was not involved when this was being standardized in DNSSEC, but there was apparently a good discussion about should it send back a different error message, not a serve fail, but a DNSSEC validation failed. And that argument's actually been brought back in the DNS operations group within IETF to say, should we revisit that and come up with a separate error message? Because right now, well, actually, it's options to the serve fails, what we talked about right now. But because right now you have no clue, the server could have failed because it's really not there, or it could have been, the authoritative servers failed, or DNSSEC configuration failed. So this has been, as DNSSEC has been more widely deployed, and people are doing this has been one of those parts of the feedback loop to say, hey, maybe we should do this a little differently. All right, any more? All right, one last one.
One last one.
And then we'll end this for here.
Yeah, thank you very much for that. Bastiaan Goslings, amongst others on behalf of Amsterdam Internet Exchange and ISO Netherlands. My apologies in advance if I not understood all the details, the technicalities of it, but I was wondering, imagine the ISP does the validation. We're speaking of a domain name, DNSSEC signed, but at the same time the ISP is instructed by government to block at the DNS level that particular domain. Besides the fact that you might argue whether that's the way to go to try and block at the DNS level, but does the fact that it's DNSSEC signed create anything additional?
I don't believe that would have any impact whatsoever. Whatever the local jurisdiction and requirements are that you're operating in, whatever the laws are there, you have to do the same thing. You have to follow those laws, and whether or not you had a name signed with DNSSEC or not, it really would not impact that.
The one thing it would do was that if you had a if you were required to send back a bogus record,
Now this is a
well,
recursive validation.
yeah, I mean, so in what you're saying, in the blocking case, no. I mean, it would have no impact whatsoever, because if you're blocking the DNS, you're blocking the DNS. So whether you get back a server failure, you get back whatever you're giving back, it's not going to matter. But while you're there, I'll mention one last piece, which is to say that the ISEC chapter in the Netherlands, along with a bunch of other folks, put out a great site called internet.nl. And if you just go there, internet.nl, there's a Dutch version, but there's also an English version right there. It will test it'll do two things. It'll test the network you're on for whether it does DNS Sec validation and stuff, and it will also test the domain name. So you can go there and test the domain name and find out whether it has the most accurate TLS certificates, whether it's DNS Sec signed and other stuff. So internet.nl, a great site to go and check your domains. And, he wasn't the plant, really. So, no, it's a good site that's there. So with that, I think we'll draw to a close, say thank you very much for coming here. We'll still be here for a few more minutes. And again, if you're interested in a lot more detail about DNSSEC, you can come to the DNSSEC workshop on Wednesday starting at 9 o'clock. It goes from 9 o'clock till 3:15. There's a whole series of different presentations. You can see the agenda online, and we have it online, right?
Yes.
It is there, okay. And it shows you, some of them are banned as novice, some are intermediate, some are advanced, so you can sit there and know. Because we're going to have the beginning of it is typically very useful because we have people from around Europe talking about what are they doing for DNSSEC deployment within their region or within their CCTLD or other pieces. And then we're going to get into some pieces around some of the different applications that people are doing with DNSSEC, some of the different tools people are using. Some of those might get a little bit more advanced in some of the ways they are, but do check it out. I'm not sure what room are we in?
Here.
We're here?
We're here.
We're here. All right, all day. Okay. Different configuration, all right. Well, so we're going to be here. Come back up here. Come to the 4th floor for DNSSEC. And with that, thank you very much.
Let me put this on.